Flowchart is your graphical representation, and next is pseudocode, which is called as the pre-format of your coding. In algorithm or flowchart, there is some kind of disadvantages are present. In flowchart, it follow the graphical representation. If you do any kind of changes, then you have to entire redraw the program. Okay, so it is a very time consuming process when you are using a flowchart. And in pseudocode, it is called as the pre-format of your codings. So that is called as the pseudocode. So now it is a just a simple question jump for you. Which one of the following tools is used to show the graphical representation of the sequence required to solve a problem?
To show a graphical representation of the sequences and steps required to solve problem. I think algorithm.
Graphically, algorithm is defined in the step-by-step process.
Yeah.
Graphically, we're using flowchart. Okay,
Oh, okay, yeah.
flowchart is called as the graphical representation. Here,
Yes, clear.
okay. So it is a short exercise for you. Uh, can you share your screen? And
Um, okay, let me share my screen.
I stop my screen share. Just a minute.
So, it actually says that you have disabled it. Let me try now.
You
So,
have
what would you like me to share?
yeah.
What would you like me to share?
Okay, I will show you. Uh,
Okay.
just a minute. You just tell me the answer. I will write. Okay. So first, write an algorithm to find out whether a number entered by a user is divisible by 5 or not. So what is the step we perform? So what we have to write first line?
So, um, so take a calculator.
What?
So, take a calculator.
Uh, First start the
Oh yeah, start algorithm.
yeah. So when you start, so first you have to write start the algorithm. Okay. So first step is just step one.
Okay.
Step one. Just start the algorithm. Then tell me the next step.
The next step is uh, get a calculator.
We want to find out
Oh, okay.
the number is divisible by 5 or not. Okay. So first we start the algorithm. Next step,
We have to put a number.
yes.
We have to put the number, and then the
Ah,
third item is that we have to put the division sign.
okay. It is a step by step. So we write the first, second step. Accept the number. Okay. Accept the number. Then step 3 is what?
Step 3 is you have to, what do you mean accept the number?
First is start the algorithm. Second is accept the number. Then
Then we have to write the first number down.
yes, we divide the number,
Yeah.
divide the number by 5. Okay.
Mhm.
Next step is what? Then we have to check whether the number is divisible by 5 or not. Okay.
Okay.
Check whether the number divisible by 5. Then step 5, if it is yes, then so number is divisible by 5. In step 6, if your number is not divisible by 5, it shows if the number not
It's not divisible.
divisible by 5,
Okay. The number is not divisible.
it is not
Divisible
divisible.
by.
It is a step 6.
Okay.
Then in step 7, what to write?
So in step 7, if it is not divisible by 5,
Everything is
so
over. So in algorithm, all the things we have written.
you have to write end algorithm.
Yes, good. So we have to write in the algorithm. Excuse me. Got it?
Yes, I have got it.
Okay. So next part,
Next one.
write a algorithm to display the 10 multiples of 9. So we have to display the multiplication table of 9.
Okay. So
First step is
first step is start algorithm.
yes, then
Then the second step is
uh,
then the second step
yeah,
is 9 times 1,
yeah.
and then the third step is 9 times 2, and then continue that until 10. Repeat that until 10, and at 10 it will be step 11, and then at step 12 you will say end algorithm.
Okay. So here you have to check. So start the algorithm, display 9 into 1, display 9 into 2, then display 9 into 3. So up to 10 multiplication table we have displayed. 9 into 1 is 9, 9 into 2, 9 into 3. So it is a multiplication table of your 9. Clear?
Yes, clear.
It is a next exercise. Write the algorithm to find out whether a number entered by a user is even or odd. So what is the even number?
So an even number is a number that is divisible by 2.
Yes. Then how you have to perform the tax? How to write the algorithm?
So you have to write the algorithm to find out whether number. So you have to do it by if. So you have to start algorithm
First
and
step
then
is first step is
start algorithm.
start algorithm. Good. Next step is
Next step is um, um, divide the number that
accept.
that has been given.
First you have to accept the number. Okay. So
Okay.
first you
Accept the number that has been given.
okay.
Next, divide the accepted number by 2.
Yes.
Next, if the num if when it is divided by 2, like
Yes.
multiple times, divide it by 2 until you cannot get you cannot divide it anymore. And if the remainder is 1, if the remainder is I'm sorry, if the remainder is 0, then it is an even number.
Okay. So let's take first start the algorithm, accept a number, then divide the number by 2. If your remainder is 0, then
Okay.
your number is even. If your remainder is not 0, the number is odd, then end of your algorithm. Okay.
Okay.
Next exercise, write an algorithm to accept the two number from the user, subtract the first number from the second number, and display the result.
So once again, can I read the instructions once again? Write an algorithm to accept two numbers from the user, subtract the first number from the second number, and display the result. Okay, first we put start algorithm,
Wait.
um, and then next we put accept number,
How many number you have to accept?
one number, accept the
One number.
first,
How many number?
yeah,
Check it again.
two numbers,
Yes.
accept two numbers.
Good. Okay.
Okay, accept two numbers,
Okay.
and subtract the first number from from the from the second number
Okay.
and display the results
Good.
and algorithm.
Good. Very good. Let's check. Start the algorithm. Accept the first number. Accept the second number. Subtract the first number from the second number. Display the result. Then end of your algorithm. Clear?
Yes, clear.
So now we move to problem solving using flowchart. The
Okay.
computer performs various tasks by following the step-by-step process. To perform these tasks, instruction needs to be provided to a computer in the form of a program. So for a NAV programmer, you writing such program in any programming language is very complex. Clear?
Yes, clear.
So therefore, it's better to break the entire program into a set of steps and to represent the same using a diagram. Tell me, who cooks the food for you in a home?
Um, my mom and my dad.
Yes. So your um, mother and your father are both helping to each other. So they divide the work. So in the meantime, or in the what, um, by the minimum effort, they are able to making the food. Okay, they are helping with each other. Clear or not?
Yes, clear.
Yes. Similar way, in your school, you have friends. If you have some kind of task that given to you, so you divide that work between your friends. Then after dividing the work, so it make the complex program as a simple. So in a program, or when you have a complex program, so it is better, do not write the complex program or solve the complex program alone. You have to break that program into a smaller part. And every smaller part is handled by the individual person. Okay, so by handle the individual person, when it is handled by the individual person, they individually solve it, then they gather it. Okay, so it's just like your mother, suppose if you prepare some kind of curry, so father is cutting the vegetables, mother is what, just processing the what, your food preparation. So when both are working simultaneously, then in the minimum effort or minimum timing, the food is prepared. Yes or no?
Yes.
So that is called as the what? Helping to each other. So when you are working with a complex programming, so it is better that you have to break down your program into a simpler one by breaking down the program into a smaller part. Clear?
Yes, clear.
So
So,
yes, tell
like,
me.
so we're changing the program into like a smaller, easier program.
Smaller program. Smaller program means suppose when we prepare a building. Okay,
Mm-hmm.
when you are prepare a building, you have plumber, you have the contractor, those are build the buildings. Okay,
Yeah.
and some peoples are there, electrician is there, which is what, giving a wiring or giving a electricity supply to your home. So it is not possible for a single person. If you give the contractor to do all the work, so it is the contractor cannot do it. Plumber cannot do it all the work. Plumber do not know how to giving a supply to the electricity supply to your home. So there, every department is divided. Okay, like in a country, the people's having what, prime minister is the head of the country, or president is the head of the country. Then under the president, lot of departments are there. Okay, like finance department, or like others, some kind of IT department is there, education department is there. So every person is responsible for their work. So work is divided. Okay, and there is a judge is present. So judge is president. The president is judging that every people is working perfectly or not. Clear?
Yes, clear.
So if I am giving all the tax to a single person, so it is not possible to do all the work. So the person become bored and it is become hectic to solve a problem. So that all the program is divided into a smaller part. Clear?
Um, what what do you mean all the programs divided into a smaller?
I will show you how it is divided. Okay, like suppose I am giving you a tax, uh, that you have to add a number, subtract a number, and divide a number. So I am giving you three tags. Clear?
Yes.
So when you when I'm giving the three tags, so it becomes the complex for you. Means at a time you cannot solve it. So you have to go for one by one. Okay. So in a calculator, you solve at a time one operation. You first add it, then you subtract it, then you divide it. Okay. So let's say I'm giving you example in the calculator. Just see the example. Suppose I'm giving a tax to see that you have to add a number. 60 plus 20, 60 plus then 20. So see that I am doing one tag at a time. Other two tags I have not performed. Okay. So if in the same time I want all the result, if in the same time I want all the result, so for subtraction and multiplication, I have to given the tag to the other person. Okay. So they one person is doing addition, another person is doing subtraction, another person is doing the multiplication. So in 1 second, you are getting all the result. Got it?
Yes, got it.
So that is called as the divide the program into the multiple part. Okay, so that what happened in the one time you are getting what all the result. So if you do one by one, so it will take the timing and it is hectic for you. So similar thing is happen in the programming world. So it is not possible for a single person. They have to do all the work. It makes the confusion. So that all the program or all the instruction is divided into a smaller part. Like your mobile phone, when anybody is calling you, so it is showing you that you have to uh, receive by the green button. When you want to disconnect, there is a red symbol is there. When you want to turn on the system, so there is a particular what switch is there. So that is
Yeah.
you have to on the switch. And if you want to giving a space, so there is a option is different. So every option or tax is different, so that we easily identify what is the purpose of each key. Clear?
Yes, clear.
Okay.
So wait. So basically, what you're saying is every task is like divided into like small group,
uh,
like like
tell
every
me
person.
tell me loudly.
So what you're saying is that every person has like a job to do in life, right? So so for the calculator, every like chip does something different. Is that what you're trying to say?
Yes, calculator is what that the calculator I have show you. So that is a one type of program, that is a instruction I have given. Okay. So similar way in the practical sector, if you go ahead in the flow chart, so there is a different modules are there. Okay, you break the modules. Okay, so it's just like that. uh, just I am giving an example for the word. um, at a time I'm giving you for addition, subtraction and multiplication, and at a time I want to get a result. Okay, so what happened here? It is not possible for all the persons to a single person to give all the answer at a time. So the three person is listening all the questions and giving a result simultaneously. So simultaneously work is performed when you divide the work. Clear?
Yes, clear.
Okay. Next is flowchart. Flowchart are used to represent the logic in a graphical form. It helps in depicting the logic in a step-by-step process. So you represent your logic in a graphical format. Previously, the algorithm we are using, we represent our logic in a step-by-step or sentence basis. But here, we represent our logic into a graphical form. So
Okay.
when you represent the information in a graphical form, it is very easy to understand. Okay, so very easy to understand. So what is happening? To help you evaluate the correctness, the logic, step by step involved in the process. To draw the flowchart, a set of symbols are used. Okay, so what are the symbols we are using? The flowchart is created by using set of symbol. So these are the symbols we are using for designing the flowchart. So this symbol is called as the input. If you want to take the input from user, it is used to take the input. Like if I am giving you tax to add the two number, so you are given the input 10 and 20. So I'm giving a task that you have to add the two number 10 and 20. So that 10 and 20 is taken by using of the input box. So it is called as the input box. Is
So
that clear? Tell me.
yeah, so this is in flowchart, right?
It is a flow chart. It called as the input box. While you are taking a input, so this input are stored in this box. Am I clear to you?
So it's a flowchart called an input box. Is
The
that right?
operation part I am showing you how it is working. It is a just symbol. So I am showing you how it is working. First, you just see what is the work of this diagram. Then I am showing you example. Then your doubt will be clear. Okay.
Yeah, excuse me. May I please go to the bathroom for 1 second?
Why?
So because I can go to, so I can go to the bathroom.
I'm not getting you. Tell me loudly.
Can I go to the bathroom, please?
Yes, yes, yes.
Okay. Thank you. 1 second, now, please.
We have it is a output box. So after adding, when it want to display the output, so here the output box is there. Okay, it display the output. Like what is the action you perform? Your output is your monitor. In an electronic device, monitor is your output. Input you are given through the keyboard and mouse. Okay,
Mhm.
and your processing is done through the CPU, central processing unit. Clear?
Not really. I don't really understand. So can you please explain it again?
Yes. In a computer, we give the input through the keyboard. Clear?
Okay. Yeah.
Keyboard and mouse we are using for giving an input,
Mhm.
and the input are processed. Like we are preparing the fruit juice. The fruit is your input. Processing that you are mixerize that through the grinder. So here, what are the input you are given? The input is processed through a CPU, central processing unit of a computer. Okay, you have a desktop now?
CPU, CPU.
I'm
Central.
showing you. I'm showing you the picture. Just wait a minute. I'm showing you the picture. You
What
have
is
to
it called? Central processing
central processing unit.
of a unit. Uh-huh.
Just a minute.
So we give information from the mouse and the keyboard, and then
Keyboard. Yes.
and then and then it gets processed through the CPU.
Yes.
Okay.
And it is display the output in a monitor.
Oh, okay.
Clear?
Yeah.
Okay. So it is called as the decision box. It is used to specify a condition for checking a condition. Suppose when you delete a picture from your mobile, or if you want to delete a app in a mobile, it is asking you, do you want to delete? Do you want to download? It is asking your permission. Yes or no?
Yeah.
So that decision has to be mentioned in a decision box. Clear?
Yes, clear.
Then by using procedure and subroutine. Procedure and subroutine, it is used to divide the complex program. Okay, means you divide your work into a smaller part. For dividing a work into a smaller part, we're using procedure and subroutine. Okay,
Okay.
and all the symbols are connected through the flow line. All the symbols are connected through the flow line. It is called the arrow mark. So arrow mark is used to connecting all the symbols. Clear?
What is used to connecting all the symbols? Uh, can you repeat that? I didn't really understand.
What is the work of flow line? That's the question, huh?
Oh, what is the word of flow line? Okay. So used to connect the steps of flowchart and indicate the sequence of its steps of
Yes, yes.
perform. So
Just
wait,
uh,
can you go back to the other page? So so basically you're saying that like it organizes the flow chart.
yes. Means when you want to connect all the symbols, means program work is what? It is doing the step by step process. So for performing the step by step, like suppose you are going to a particular place, so it is showing you take the left side, it is showing you arrow mark, take the right side. So it is directing you. You have to took that place, you have get that particular place. Okay, you go in that way and you reach that particular place. So it is showing you the arrow mark. The similar way, this arrow mark is connecting all the symbols. Understood?
Mm, no, not really.
I'll show you. I'll show you what is the thing. Don't worry. Just a minute. This file is open. See that. This diagram is a flow chart. Here we're using arrow mark. Okay. This arrow mark is connecting all the symbols. Clear? All the symbols are connected. That means
Yeah,
it is giving a direction to down. Means it is the first step, it is the second step, the third step. Clear?
yeah.
So
So what does flow line mean?
what is the it is a flow line. This symbol. Okay, it is called as the
Uh-huh.
flow line. Clear?
Yeah, but so what's the difference between this and an algorithm?
What is the difference between
This and an algorithm.
algorithm is represent in a step by step format, means it is written in a English word, but here it is represent in a diagrammatical format. Okay, in algorithm were written the statement like step 1, step 2, step 3, but here from the graphic you can understand it is the first, it is the step 1, then you are going to the down, the step 2, then you are going to the down, step 3, then you are going to down, step 4. Clear? The
Yeah.
diagram is representing which one step 1, which is the step 2, which is the step 3, which is the step 4. Clear?
So so the difference is, yeah, the difference from algorithm and flowchart
Hmm.
is that here you put arrows and there you put like step one, step two, or like here you don't put like step one, step two, like you can see it.
Difference between the flowchart and algorithm. First difference is what? In algorithm, you represent your information in a text format or you have to write a in statement. Okay, like here we perform. Okay, so
Yeah.
here we perform what? We are only write the statement. We are writing only sentence. Okay, so it is what? First, it is for understanding it. First, you have to read it, start the algorithm, accept the number, divide the number. But if you look here from this symbol, you can know that you will know that this symbol is for accept. But here for accepting the input, we are writing a statement, accept the number, divide the number. It is a process. But here we represent this process in a rectangle. This one, it is a process box. Is that clear?
Wait. Can you do like something like? Can you do? Can you do? Like I don't understand what. So here, would you also put accept number?
Some number.
No, like say like you are doing the calculator form for flowchart. Here, would you also say accept number?
Here, see that another example I am showing you. Just a minute. This is the animation which is accept a number and increment by 1. Okay, so it is helping you. Okay, this example is helping you.
Okay, so flowchart accept.
Start. See there. Again, I play it. First start. Accept a number. So we accept this number. It is a input box. Then here it is a processing box. 8 plus 1. Then here it is showing you the display. It is showing you the output box. If you represent in the algorithm, so how you represent this into algorithm?
You put start algorithm, step 1, start algorithm, step 2, accept number.
So first what to write? Start the algorithm, then accept the number, then next step you have to perform add 1 to number. Next step it is showing you display the number, then end of algorithm. See there. If you compare this one and this, it is visible the two screen. It is a flow chart. It is an algorithm. Clear?
Yeah. Yes. Clear.
First start. Then here we write start the algorithm. Then it's saying that accept a number. It is an input box. So here we only write the statement accept a number. Here it is called the processing box. So here we have defined the process. Add 1 to the number. Then here for display the output we are using display box. Here we are using display the number. Then here we are using end of your flowchart. Here we have mentioned end of algorithm.
Okay.
Clear?
Yeah.
In algorithm, we are writing in a sentence basis. In flowchart, we represent in the diagram basis. When you represent anything in a diagrammatically, it is very easy way to understand any paper. So if I am telling you apple, so if I write here apple, so here we only read the word apple, but we don't know how the apple look like. So if I put here picture, apple picture here, then you coming to understand, yes, it is apple. Okay, so here, what is that I have written? It is what? Read it.
Yeah.
It is apple.
Yeah.
Now, if I graphically define you, see that if I'm showing you picture, see that this picture is also represent you apple. So we have written apple in a word. Here we have represent apple in the diagram. So when it is diagrammatically defined, then it gives you the better logic or better
Yes.
way to understand anything. Clear?
Yes, clear.
So it is the difference between your algorithm and flowchart. Algorithm that you written in a step by step in a word basis or in a sentence basis. Okay. But algorithm which is giving you in a diagrammatically format or graphical basis, which is easy to understand.
Okay.
Okay. So now I
Right.
am going to other symbols that we have not covered. Okay. So it is a flow line which is connecting all the symbols. This symbol is called as the starting and ending, initiator and terminator of a flowchart. It is called as on-page connector. On-page connector is what? Suppose if I write any statement here, anything I have written, but at the end, here I want to write student. S
Okay.
S T. Just a minute. U. So in the line, I'm unable to write. So when I'm unable to write, I mark it as a hyphen. Then I start or continue from it. So we can read here, it is a student, student. Means the word is starting here as because it is not having enough space to write dent. So we mark it as a hyphen. That means it is continue from the beginning of the sentence. Clear?
Yeah, it is clear.
Just tell me. Oh, Sri?
Hello.
Huh?
Um. So. Uh. So. So what's next? What do we do next?
It is called as the word. You are asking,
Hyphen.
it is a hyphen. Why
No,
it is?
I know what. Sorry. Sorry. Yeah, I do know what a hyphen is. Sorry.
uh, Okay, so it is used actually. See that
Okay.
if you written something here, so I have written some word here. Okay, so here I
Mm-hmm.
write some word, but in the space, the space is given me here that you have to write a student. So when I want to write a student, then here there is no enough space is present because student is required what student, but here your space is not available to write all the word here.
Yeah, clear.
So
Yeah, I understand.
to continue it without wasting the space, so here I am defining hyphen, then you write here d and t. So you together you can say it is a student. You can write, you can spell it out, it is a student, student, because st we have written here for writing udnt. As there is much space is not available, so we define a hyphen, then we write UDNT. So when you spell, then you can spell us together, like you spell as a student. Clear?
Yes, clear.
Similar way, when you draw a diagram, so when your one page is over, so this part is over, then if you want to continue your diagram in the same page, okay, you draw the diagram, but it is not complete in one page. In the same page, if you want to continue, then we are using on page connector. Clear?
Yes, clear.
Then next part is your off page connector. Off page connector is what? Suppose when you have a question paper, if some question is written in the page number 1 and it is continued to the page number 2, so if there is question is present in the page number 2, it is showing you in the last end PTO. That means your question is present, half of the question is present in the next part. So that it is showing you please turn over, then you have to having remaining part of the question. So that is called as the off page connector. So when you draw a diagram, if your diagram will continue to the next page, then here we're using off page connector. Here,
Yes. So what does the off-page connector look like?
off page connector is required. Suppose when you want to define a large programming problem. Okay, suppose if you want to define a logic or program or instruction for a bank, the banking system is a very huge. So it is not possible to represent entire banking system in a one page. So you have to continue to the next page. So in that cases, you require the off page connector, means page 1 is connecting to the page 2. So that we're using this off page connector. Clear?
Oh, yes, clear.
Next
But
is, tell me
how does it look like though?
how it is working.
No, how does it look like? Look, how does it look like? Okay. Look.
Okay, okay, I will show you. Just a minute.
Okay.
Just a minute, it's loaded. So have you see this picture?
Yes, I have.
Yes, see that.
Yes,
Uh, it is this block. This block is one page, page number 1. This block is page number 2. See that here it is written page number 1 of 2, page number 2 of 2.
Okay.
Okay. So now we draw this flowchart. Now when I draw the flowchart, it is not over here. Okay. When it is not over and I want to continue to another page, then here I have to use a connector. So this is called as a connector. I want to connect into the different page. So here we're using off page connector. This symbol is called as the off page connector. Okay, so we left here and again we starting from here. Okay, it is the word first page we're ending here by using connector. In the second page we start with that connector. That means this flow chart in the page number 1 is not over and it is continue to the second page. Clear?
Yes.
Okay. On page connector is what I am showing you here.
Green truck. They run again. I don't have it. Green truck. Green truck.
Hello Sri, are you there? Sri? Hello?
Hello? Sorry. My brother was looking for his green truck.
Okay. See that. Here this symbol is called as the on page connector. Okay. If you want to connect the symbol with the same page, then here we are using on page. This is a on page connector. Clear?
Yeah. So 1 second.
Uh,
So so do we have to put the A in the middle, or I'm not understanding? Do we have to put the A in the middle of the on-page connector? So the on-page connector is a circle, right?
yes, this circle, this one. This one is called as the on page connector. Means if you want to continue in the same page, if you want to continue the diagram in the same page, this circle is called as the on page connector.
But why is it called alga? And why is there an A in the middle of it?
A is the identifier. That means when I connect to the from the other page or other side, the A is identifying that it is the identifier. Means I have to start with the A. You can write here B, C, D, anything. It's just like a identifier or mark. So when I start from the other part, so it is identifying that A, I left that diagram from A and I have to start the diagram or work from that A. Clear?
Yes, clear.
Okay. Your school has opened? Yeah, closed.
No, they're actually closed, and we're doing online school from home.
So now
I have
online classes are going on.
yeah, and I have 2 elective classes.
Okay.
So, do you know what elective classes are? No, do you know what elective classes are?
Electric class?
Yeah, elective classes.
Okay.
So they're like classes you get to choose. Like classes you not everybody has. Like some people have like drama or like drama or like create or like writing teacher.
Okay.
So like that you get to choose if you have them. It's not like math or English like everybody has them. So I had two elective classes. I had three elective classes, and two of them are with computers. So the first one is media tech,
Okay.
and then the second one is digital tech.
Okay. And what are the subject you have?
Um, so I have drama, digital tech, media tech, math, creative writing too, English, history, science, language arts,
Okay.
social studies. I don't know if I said that, but I think that's all.
Okay. Okay. So here, this last part of a flowchart is called as the annotation. Annotation means the description. Means here we are written what? This part we are written drawing a flowchart. So it is called as the what? Heading. It is describing what we have written here. So this part you can say it is a heading. Just a minute. This part is called as the heading. That means is describe what we have written here. So we have written for drawing flowchart. We are giving a heading. Okay. So in your when you are making a notes, so we are you are also giving a heading of that. So the annotation is just like that. So what you are performing or what is the heading that you are going to work with the flowchart, so you have to mention in the annotation part. It is used to insert a comment in a flowchart. Comment can be inserted in the flowchart to explain the step. Okay. For explaining the steps, comments are used. Clear?
Yes.
Now I'm going to show the simple flowchart. What have we have read here? It is a flowchart that withdraw the amount from an ATM. So it is called as the starting of the flowchart. Clear?
Yes, clear.
It is a input box. Insert your ATM card. It is a input box which is taking the input from the user. Then here it is showing you the ATM machine. Check your card details. That is used for checking the card details. Then it is showing you enter your PIN number. This is a processing box. So when you are insert the ATM, so it check your ATM is working correctly or not. Then we provide the input, enter PIN number. Then again processing is happened. So when you give a PIN number, it will check that the PIN you have given is correct or not. Then after that, by using press cash with receipt button, then we're using here enter the amount you want to withdraw. We're giving input how much you want. Then your processing is happened. Collect your ATM card. Then next collect the statement. After you get the money, you get the statement. What are the transaction is happened? Then your end of your flow. Understood?
Yes.
Again, I explain. Start the flow chart. It is a
Okay.
start. It is a terminator starting and ending position. Clear?
That's clear.
Now we're using a input box, which is used to insert the ATM card, means first we are giving to the ATM machine. Then ATM machine check your card details, that whether your machine or your ATM is valid or not. The processing is happened. So it is showing you your name. Then it is asking you enter your PIN number. The screen is asking you enter your PIN number. Then you have to give your PIN number. Then again processing is happened. The ATM machine validate your PIN number, whether you are correct PIN has given or not. Then press cash with receipt button. Then enter the amount you want to withdraw. It is a input box. The amount I am typing here, 2000, 3000, that you want, you give it. Then your processing is happened. Collect your ATM card. We take our ATM card from the machine. Then we collect the amount from the ATM machine. Collect the statement from the ATM machine. Then end of your closure. Clear? Is it clear?
Yes, it
Clear?
is. Yeah, that's clear.
Okay.
Yeah, that's clear.
Then this one is increment the number. Start, accept a number. We are given a number is 8. Then we add a number, 8 plus 1. Then it display the result 9. Then end of your closure. Okay.
Okay.
Which one of the following symbol is used to insert a comment in a flowchart? You can say comments, or you can say it is a heading. Which one is used?
So on page connector, I think.
On-page connector is used to connecting your symbol from one page to the another page in the same
Oh,
page. Off-page connector is used to connecting the symbol from one page to the another page. On-page connector is used to connecting the symbol on that same page.
I'm not sure then.
I'm given now. It is a heading. What is that? Just a minute. It is a heading.
Just a minute. So,
It is what?
this is decision. Oh, annotation. Okay.
Annotation. It is a annotation. Correct. It is a annotation. Clear?
Okay. Can you explain annotation to me again because I don't think I got it.
Annotation is called as the comments. Like here we are giving a comment. Just a minute. The comment. It is a heading. Okay. It is describing what we have given here. So that is called the annotation. Okay.
Okay.
Next, which one of the following symbol is used to connect one step in the flowchart to another step on a different page?
So one second. Off page connector.
Off page connector. Good. Correct answer. The off page connector. Next, we move to the rules that you have to follow while drawing a flowchart. While you have to draw the flowchart, what are the rules you have to follow? The entire logic means the step that you want to define. The entire logic is representing using the standard symbol. So you have to use a standard symbol. The flowchart should be clear, precise, and easy to follow. It should be clear, it should be precise and easy to follow. The flowchart have only one start point and only one end point. Starting and ending position must be same in a flowchart. The flowchart should have only one start point and end point. The steps in the flowchart is represented by using of flowchart symbol. The symbol we have learned: starting terminator, off page connector, on page connector, annotation. So what are the logic and what are the statement you want to write? You have to write by using the flowchart symbol. All necessary imports should be listed in a logical order because your program is follow the step-by-step process. So you give the import in your logical order. The input, process, output, and display symbol should have at least two flow lines. It must contain the two flow line, one connecting to the previous symbol, another connecting to the next symbol. So when we're using the flow chart, it is what? This symbol, one connecting the next and another connecting the previous. This one. Okay, one connecting next, another connecting the previous. So every flow chart should have two flow lines. But in the case of decision box or decision making symbol, it will contain, that is, three flow line. In other symbol, it has the two flow line. In decision box only, it contains three flow line. Clear?
Yes, clear.
Okay. The input, process, output, and display symbol should have at least two flow line, one connecting to the previous symbol and other connecting to the next symbol. The decision symbol should have two flow line flowing out of it. Means it is flowing out of it. It contains two flow line. Flowchart should have the page connector if it wants to connect to the multiple pages. Okay, if you want to connect with the multiple pages, then we're using page connector or page connector we're using. The logic of the flowchart should be checked by using flowchart some sample value. So after drawing the flowchart, you have to check whether your logic is correct or not. For checking your logic is correct or not, we're using what? Some kind of sample value. By taking some kind of sample value, you check your flowchart is correct or not. Clear?
Yes, clear.
Next, it is a question for you. Which one of the following approaches can be used or can be followed while creating the steps in the flowchart? Which approaches you have to use?
We took the final purchasing result. So I'm not exactly sure about this. So,
Follow
but
one while
so
creating.
I think it might be um I think it might be top to bottom and right to left.
Which option is correct?
I don't know.
Okay. Button to top means flowchart will contain from button to top. Means row is given from button to top.
Bottom to top. Okay. Why?
It is not button to top because flowchart is what? Button to top means the row is directing to the upward, but here the row is directing to the downward.
Mm-hmm.
So it is not button to top. It is incorrect. Got it?
Yeah.
Okay. Next
Wait,
is
wait,
yes,
it's not bottom to top. Yeah, it's top to bottom, right? It's top to
yes,
bottom, right?
it is top to button because when we write the statement or read the statement, we
Yeah.
read from left to right. Okay, so it is follow the left to right, top to button. Okay, so it is a top to button is the correct word. Clear?
Mm-hmm. Yes, clear.
Uh, Draw a flow chart to accept the principal, rate, and time values and display the simple interest. Do you know the formula how to calculate the simple interest?
Yes, I think so.
What is the formula?
I'm not sure if it, I'm not, I'm not exactly sure what this. I'm not exactly sure what the simple interest is. I think I learned this a long time ago, but I'm not sure.
Simple interest formula is what? Like principal rate in time. So I'm showing you the exercise, then you will get to know. So we have to use the flow chart here. Start for the flow chart, then input P, input R, and input T. P for principal, R for rate of interest, T for timing. Means input P means what is the money you are lending from others, or you what borrow from others. Rate when I borrow lending from money or I have take the loan from a bank. So what is the rate of interest? So that is defined by R. Then what is the time period? In how many time, how much time I will take that money. So that is defined by the T. So based upon these three, I have to calculate the simple interest. Okay, the interest rate will be calculated P into R into T divided by 100. So after defining this, it displays the simple interest. Then end of your flowchart. Here,
Yeah, it's clear.
what is your favorite game that you want to play?
Um, mm,
Which game you are liking most and you are playing with your friend?
um, the most I'm playing with my friend is Minecraft.
What?
The most is just Minecraft.
Okay. How many best friend you have now?
Um, one best friend, right? Everybody only has one best friend, right?
You have only one best friend.
Yeah.
Okay.
Everybody can only have one best friend, right? Nobody can have two best friends. That's not allowed.
Yes, yes, yes.
But I have like, there's like, I have like 20 friends. But I only have one best friend.
Okay. You are in the same class. Your schoolmate, yeah, your coaching mate.
Sorry, what?
Your schoolmate, yeah, your neighbor.
My neighbors and my schoolmates, they're both.
Okay. So next, draw a flow chart that accept a number and display its Q. Do you know the formula of Q?
Formula for Q? Maybe, I'm not sure. Yes. I think I forgot that too.
What is the formula?
Yeah.
Suppose you have a number and if you want to find out Q of that number, if your number is suppose num1, then if you want to find out Q, then num1 multiplied num1 then multiplied with num1. So we multiplied the 3 times. Okay, so that is a Q. So if you want to find out Q of a number, you multiply the number 3 times. Clear?
Yes, clear.
So start, then input in, we're taking a number, then we multiply the number, cube equals to n into n into n, we multiply the 3 number, then display the cube, then end of your flowchart. So start, we have taken the number is, uh, if you want to take any number, it is represented inside the input box, then we multiply it, n into n, then display the cube, then end of your flowchart. Here,
Yes, clear.
what is the timing now there?
The time here is 10:22, so there are 2 minutes.
10:53.
There's 8 more minutes. I mean 7 more minutes.
Okay. So, do you know what is the area of rectangle? The formula?
Yeah, length times width.
Area of rectangle?
Length times width.
Yes, length into breadth. And your perimeter?
Perimeter, length plus width plus width.
Yes. You write the formula in the chat box. The chat box is present.
Sorry, can you repeat that? I didn't hear you.
You tell me the formula, or else you write the formula on the chat box in Zoom.
Okay.
Okay.
1 second.
I have sending you message. Hi. Yes, good. You can also write this part as to length.
Mm-hmm.
Okay, you can write in this way also.
Okay.
Okay. Start, then for accepting, you have to accept the length and breadth of the rectangle. Then for finding the area, the A is represented for finding the area, A equals to L into B. Then for getting the perimeter, P equals to 2 into L plus B. 2 into L plus B. Then display area and perimeter. Then end of your flowchart. Here.
Okay. Yes, clear.
So today we have discussed about the different symbols of flowchart, like start, end, the different symbol we're using. We cover the different exercises, and in this session we learn about the uh, advantages and disadvantages of the flowchart and what are the rules we have to follow. So when you draw the flowchart, you have to remember all the logics to be represented in the form of a symbols, and as well as you have to join all the symbols through the flow line. The flow line should be top to button, left to right approach. The flow symbol you have to write. Then there is only one start point and end point in a flowchart. If your flowchart will move to the next page, and if it is continue to the lengthy part, then you have to use the page connector. If you want to continue the flowchart with the same page, then we are using on page connector. If you want to continue the flowchart to the next page, we are using off page connector. So on page and off page connector is used if your flowchart moving to the next page. And the different you put all your logic by using of different symbols. There is some kind of conditional symbols are present, some kind of repetition symbol is present, that we have to discuss. And while or after drawing the flowchart, you have to check whether your logics are correct or not. If your logics are correct, for checking that, you have to take some kind of sample value and check one by one or check every step whether it is accurate or correct or not. Here,
Yes, clear.
okay. So in next class or tomorrow, we go for this one, conditional and repetitive process. Clear?
Yes, clear.
Good night.
Good night.
Bye bye.
Sorry, can you repeat that?
Okay. We may leave now. So in the next class, we cover. Okay. Thank you.
Okay, bye.
Bye bye.